series going on, and this is the 10th lecture of that series, Environmental Engineering. Myself, Soumyajit Sen. We will discuss about this environmental engineering. We have been discussing for last 10 days, 9 days. Before going to the topic, I want to just give you just telling you that if you don't have the Unacademy learning app, just a reminder, type there in your Play Store Unacademy learning app and install that learning app. In that learning app, go to GATE and ESE, as this is the GATE and ESE courses. We are going for the GATE courses, GATE and ESE, and there click there, go for the plus course. Unacademy Plus course is the course where you will get all the top educators of Unacademy along with some personal mentorship, examinations modules, etc. and all. So we'll suggest to go for this plus course and subscribe the plus course by subscription. Get subscription button by clicking the get subscription button. Don't be late. Go for the subscription of plus course. You will get a lot many things. You will get my classes over there in detailed concepts and all. And then go for, even while taking the subscription, don't forget to apply the SEN10 code, ACN10. That is my code. Don't forget to apply my code SEN10 ACN10. Don't forget to apply my code ACN10 SEN10. It is my code. Don't forget to apply SEN10. Don't forget to apply. This is my code. So and SEN10, and this is a very great news. Very great news. You can say it is nothing but the new year gift to the students, civil engineering students, GATE aspirant students for Evolve GATE 2022. Those who are actually aspirants for GATE 2022, buckle your seat belt. 28th December 11:15 a.m. Unacademy is launching English and in the both language, English and Hindi, civil batch A, Evolve for GATE 2022. Evolve for GATE 2022. English and in English and in Hindi starts on 28th December 11:15 a.m. Starts on 28th December 11:15 a.m. And another good news for the students, and before going to that, while subscribing for this course, don't forget to apply SEN10 ACN10. Don't forget to apply SEN10 for this course. Apart from this, another great news that 29th of December, exactly 1 day after, from today there is 2 more days, 29th of December. If you are not registered, register now. Unacademy Combat, next combat goes live on 29th of December 6 p.m. Enroll for free. In this combat, you will get your position by competing with the like-minded pupils. Register now for the next combat. To unlock, use the code CRACKGATE, CRACKGATE. For this combat, generally question paper will be set by the topmost educators. Topmost educators of the Unacademy. You will be provided with the live video solution after the combat. Exciting prizes are there. For rank 1 to 3, you will get 3-month subscription or the equivalent Amazon voucher. Rank 4 to 50, you will get rupees 500 Amazon voucher. Once again, Unacademy Combat. So before starting the topic, I'm just recalling the thing that 28th December 11:15 a.m. the batch Evolve for GATE 2022 Civil Batch A is going to launch. English and in Hindi. Buckle your seat belt. Don't be late. It's better to start early. So in Unacademy, let's crack it. Now, so today we are going to discuss. We are going to complete the treatment of water and even the domestic water supply part. This segment, we are going to complete this segment. apart from distribution system. Distribution system I will deal later. So treatment of water we are going to discuss today. Chapter 4, treatment of water, is continuing. We are going to discuss about the disinfection process. So till yesterday, if you remember, till the last class, we have already discussed about the filtration technique. So while discussing the treatment of water, I have already told you that we are actually concerned about two type of impurities. One is particle, another one is microorganism. The particles means according to the sizes, it will be of three type: suspended particle, colloidal particle, and the dissolved solids. Suspended particles, we have dealt with the process of plain sedimentation process. Colloidal particle we have dealt by coagulation and flocculation, and the dissolved solids we will deal with. We have dealt with filtration process. The final thing for the surface water treatment, which is same for the groundwater also, that is disinfection process. That is disinfection process. So in disinfection process, let's go with the thing that we are going to discuss about. The disinfection process means we are going to deal about the microorganism. The microorganism parameter, there, how to quantify them, how to qualify the water, we have discussed in the quality of water chapter. So disinfection is the process where that will be a tank called as disinfection tank, and there we will put certain chemicals from outside, or it can be done by certain physical way also, and that is called as disinfectant. And after some time, after a period, we will get microorganism free water which we needs to supply. पहले एक टैंक लेंगे, उस टैंक को कहते हैं डिसइंफेक्शन टैंक. उसमें कुछ केमिकल्स फ्रॉम आउटसाइड, या तो कभी कभार कोई फिजिकल मेथड से भी हम लोग उस पानी को डिसइंफेक्ट कर सकते हैं, उस पानी से माइक्रोऑर्गेनिज्म को हटा सकते हैं. एंड फाइनली द माइक्रोऑर्गेनिज्म फ्री वाटर, जो माइक्रोऑर्गेनिज्म फ्री वाटर हमको मिलेगा, दैट विल बी सप्लाइड. मींस दैट विल बी supplied. So depending on the type of disinfectant tank used, disinfection method will be classified under unit operation or process. Depending on type of disinfectant use का मतलब है, कभी कभार केमिकल मेथड यूज होते हैं, जैसे हैलोजन ग्रुप ऑफ केमिकल, या तो कैल्शियम ऑक्साइड, या तो पोटेशियम परमैंगनेट, या तो ब्लीचिंग पाउडर, और it may be ozone. If you are using certain chemicals from outside, then obviously disinfection will be unit process. Now, sometimes disinfection is carried out by, sometimes disinfection कभी कभार physical method से भी हो सकते हैं, जैसे by applying light, by applying heat. So when this is done, then it will be as a disinfect unit operation. So your plain sedimentation is predominantly unit operation, coagulation flocculation is unit process, filtration is unit operation, and disinfection, it can be unit operation, it can be unit process, depending on the disinfectant or mode of disinfection. Depending on the mode of disinfection. Now, we're going for a very important term that is called as residual sterilizing effect. We're going for a very important term that is called as residual sterilizing effect. इसको समझना है आपको. क्या है कि suppose in the tank you are supplying suppose in the tank you are supplying certain disinfectant, or you are providing water, and you are providing water, and you are providing the disinfectant. This is a particular tank. Okay, you are providing certain disinfectant. Now after this tank, you will get microorganism free water. That part is okay. Now the water will not get supplied just after the disinfection process. Water will get supplied. Water will get supplied after lot many struggle through pipelines. क्योंकि बहुत सारे पाइप, अगर आपको एंड तक, मतलब एक कैचमेंट एरिया का एंड तक, एंड वाले घर तक आपको पानी सप्लाई करना है, जहाँ बहुत सारे pipeline से water will be traveling. Now during that traveling process, is there any kind of guarantee that the water is not getting infected once again? Can you give any guarantee that the water is not getting infected once again during the traveling process? You will not be able to give any guarantee. So what you will do, you have to applied amount of disinfection should be more than the demand. So suppose this is your expenditure and this is your salary or what you are earning, then only certain amount is going to get saved. So applied amount more than the demand, because we are actually fond of the residual amount, and the residual amount you will get by applied minus demand. The residual you will get by the process of application minus demand. So what actually I am trying to say? I am trying to say that you need to apply more than the demand so that residual amount persists in the tank. And what is the effect of the residual amount? The residual amount of disinfectant will protect the water from further from further contamination. This residual amount will protect the water. Residual amount will protect the water from further contamination. From further contamination that can happen in the pipelines during the traveling of water or during the conveyance of water, treated water to the households. So this thing is called as residual sterilizing effect. This thing is called as residual sterilizing effect. This thing is called as residual sterilizing effect. So residual sterilizing effect is required. Why? Because this residual amount will protect the water from further contamination. The residual amount will protect the water from further contamination. This is called as residual sterilizing effect. So that is written here. The amount which will be applied have to be more than the required amount or demand amount, so that residual amount persists in the system. This residual amount will ensure disinfection process during the distribution of water. The residual amount will ensure the distribution process, ensure the disinfection during the conveyance of water through the pipelines. Now, the certain requirements before choosing the disinfectant. Certain requirements before choosing the disinfectant. First of all is effective and efficient killing. First is effective and efficient killing. Effective and efficient killing means complete destruction. It should not happen that 50% is getting killed and 50% is remaining in the system. That means that 50% will further create issues. So effective and efficient killing means the complete destruction has to be ensured. Effective and efficient killing means the complete destruction has to be ensured. Second one is fast rate of killing. Quickly it should kill the microorganism. Fast rate of killing. Quickly it should kill the microorganism. Should have enough residual power. Should have enough residual power so that it can protect the water from further contamination during the distribution of water. Should have enough residual power. And that is the reason you will sometime, if you are staying in a municipal area, they are just putting like bleaching powder is actually a form of chlorine. We will discuss that for disinfection process, and sometimes you will get the smell of bleaching powder because very excess bleaching powder is provided. Okay, should be detected easily. If it is not getting detected easily, then there will be certain problem while dealing with this disinfectant. Should kill the microorganism, not the human being. Should kill the microorganism, not the human being. That means it should not be toxic to human being. It should be toxic to the microorganism only. It should not be toxic to human being. So I am repeating once again, effective and efficient killing. That means the complete destruction. fast rate of killing, quick killing process, should have enough residual power. That means the it should save the water from further contamination during distribution process, should be detected easily. Otherwise it will not uh, the process will not be complete, because if you are spending more time to detect your thing only, it is not at all a good process, and should kill the microorganism, not the human being. That means it should be toxic to microorganism, that is good, but it should not be the toxic to human being, so that the persisting amount or residual amount is creating certain health hazards to the human being, वो नहीं चलेगा। अगर आपका ही डाला हुआ, आप अपने खुद को बचाने के लिए कुछ डाल रहे हो, वो चीज ही आपको ही मार रहा है, so it is not going to be a good disinfectant, or God not going to be a good uh, what to say ammunition for this battlefield weapon. Now the mechanism of disinfection, how any disinfectant can kill the microorganism, किस तरीके से ये लोग मारते हैं। फर्स्ट ऑफ ऑल माइक्रो ऑर्गेनिज्म क्या है कि अगर हम देखेंगे तो ये लोअर ग्रेड लिविंग सेल्स हैं, जिसका सेल वॉल रहते हैं, और जो सेल वॉल एक्चुअली क्या है कि ये सेल वॉल आई कैन जो सेल वॉल का मैं बात कर रहा हूँ, दे आर जनरली permeable cell wall, permeable cell wall from outside to inner side. Anything can enter as per the requirement of the microorganism. Inside there will be nucleus, cytoplasm, all those things are there. The point is, as it is permeable cell wall, well, semi permeable cell wall, it's nothing can go out from the system, anything can come in. Semi permeable cell wall, so if you make the cell wall impermeable, eventually it will not get food and it will die. That is the first point, that cell wall impermeable. Destroy the cell wall, once again you're destroying the cell wall means you are destroying the protection shield, as well as you're destroying the food taking segment. Destroy protoplasm, and quite obviously if you are destroying the protoplasm, the protoplasm is nothing but the CPU of a computer, like this thing. Protoplasm to the microorganism is nothing but the CPU of a computer. If you are destroying the protoplasm, then also microorganism will die easily. Now methods of disinfection, how the disinfection process will get carried out. The disinfection process will get carried out by two methods I have already told, that is physical method, another one is chemical method. In physical method, you are applying certain physical forces. In physical method, we are applying certain physical forces to carry the disinfection process. Whereas in chemical methods, we are applying certain chemicals from outside. If you are carrying the disinfection process by physical method, then the disinfection will be called as unit operation. And if you are going or doing or executing the disinfection by applying certain chemicals from outside, it will be called as unit process. Physical methods can be executed by applying heat or by applying light. Physical methods can be executed by applying heat or by applying light, whereas the chemical methods will be executed by applying excess lime, first of all, number 2 by applying metal ions, number 3 by applying ozone, and number 4 by applying halogen group of chemicals. So, apart from these four, by applying potassium permanganate is also there, but generally this using of potassium permanganate is done in the village area or rural area, and it is not widely used. That's why we are not discussing. But this last chemical method by applying halogen group of chemical is the most important one of this segment. Is by applying halogen group of chemicals, we will discuss in details along with its kinetics. But before that, these five: heat, light from physical, lime, metal ion, and ozone from chemical. These five we will discuss in brief along with their advantage and disadvantage, so that we are getting some glimpses how the disinfection methods is getting executed. Okay, so next is, first we will go for by applying heat. अगर आपको याद है तो फर्स्ट वी एंटर इनटू द फिजिकल मेथड, और फिजिकल मेथड में पहला ही पॉइंट था बाय अप्लाइंग हीट। अगर आपको याद है तो ये चीज आपको याद रहना चाहिए कि जब टेम्परेचर हम लोग पढ़ा रहे थे क्वालिटी ऑफ वाटर चैप्टर में, आपको मैं बोला था कि टेम्परेचर माइक्रो ऑर्गेनिज्म का जो टेम्परेचर रेंज है वो नॉर्मली 20 से 35 डिग्री सेंटीग्रेड के बीच जो होता है कि उसका ग्रोथ जो है वो एनहांस होते हैं। Microorganism growth generally enhanced in the temperature range 20 to 35 degree centigrade. But if you increase the temperature, what will happen? The cell wall of the microorganism destroyed immediately. If you increase the temperature, the cell wall of microorganism will destroyed immediately. Now, अगर 60 से 65 तक 60 से 65 तक आप टेम्परेचर लेके जाते हैं तो most microorganism will die. At temperature at the range of 90 to 98 degree centigrade, all will die. तो ये सारे बातें में बहुत बार हो चुका है कि इसको बॉयल हम लोग देखे हैं बचपन में, बॉयल करते हुए पानी को ठंडा करते हुए फिर पिलाया जा रहा है। तो एक्चुअली effective and efficient killing is ensured here. Effective and efficient process, fast rate of killing is also ensured. What is the disadvantage? डिसएडवांटेज है क्या? आज में आप कुछ पानी को उबाल रहे हो और फिर 10 दिन बाद पी रहे हो, यू कांट गारंटी कि भैया उस पानी में अभी तक कोई माइक्रो ऑर्गेनिज्म नहीं है, तो नो रेसिडुअल पावर, रेसिडुअल पावर एकदम भी है नहीं। और अगर इस प्रोसेस को डोमेस्टिकली आप यूज कर रहे हो, घर पे यूज कर रहे हो, एक बकेट पानी ले रहे हो या एक गमले पे ले रहे हो, दैट इज डिफरेंट इशू। लेकिन अगर इफ यू आर यूजिंग इट इन अ बल्क प्रोसेस, मतलब बहुत बड़ा जगह पे कर रहे हो, एक कैचमेंट एरिया की कर रहे हो, कोई हाउस होल्ड्स के लिए कर रहे हो, कोई एक कम्युनिटी के लिए कर रहे हो, तो इतना ज्यादा फ्यूल कंजम्पशन होगा कि दैट विल बी नॉट बी इकोनॉमिकली वायबल। For bulk process, fuel consumption will be very high, which is not at all economically viable. Okay, that is all about the by applying heat. Have a look. Now we are going for by applying light. By applying light means it's not about the sunlight part. Generally, it is called as UV ray treatment. In your domestic water the treatment unit, like whatever you are putting in your houses, Kent, RO, Dr. Aquaguard, lot many things are there. So by applying light is called as UV ray treatment, where lambda, the wavelength is 250 to 260 nanometer UV ray, is having very high disinfection power. Lambda 250 to 260 nanometer UV ray is having very high disinfection power. Instant killing by killing the destroying the protoplasm. Instant killing is ensured. Instant killing by destroying the protoplasm. Advantage is effective and efficient killing. Effective and efficient killing. Very fast rate of killing. Very fast rate of killing. The only disadvantage is future protection is not ensured. Effective and efficient killing, very fast rate of killing is ensured. Future protection is not ensured. Matlab residual power is not there. Residual power is not there. Now, the effectiveness of disinfection by UV rays will be governed by an equation. The effectiveness of disinfection by UV rays will be governed by an equation ln Nt by N naught is equal to minus K into I into T, where Nt is the number of microorganisms left at time t, N naught is the initial number of microorganisms, K is the rate constant, I is the intensity of UV rays in microwatt per meter square. I is the intensity of UV rays in microwatt per meter square, and T is the contact time in second. Contact time मतलब कितना time your UV ray is actually getting contacted, कितना time पानी के साथ हुआ है. So that is the equation by which the effectiveness of disinfection by UV rays will be governed. ln NT by N naught is equals to minus Ki into T. Nt is the number of microorganisms left at time t. N naught is the initial number. K rate constant. I intensity. T is the contact time. I intensity in microwatt per meter square unit. Now question is why this negative sign is coming? Why this negative sign is coming? The negative sign is coming because when time increases, number of microorganisms get decreases. When time increases, number of microorganisms get decreases. That's why this negative sign is coming. Okay. Now I'm going to put a question, mm, show you how much effective the process is. Just have a look on the question and try to solve it. I'm giving you 1 minute time. Find the time of exposure of UV rays required in water to reduce the microorganism from 10 to the power 6 to 100 by exposing UV rays to intensity 30 watt per microwatt per meter square, where K is 6 into 10 to the power minus 3. Find the time of exposure of UV rays required in water to reduce the microorganism from 10 to the power 6 to 100 by exposing UV rays of intensity 30 microwatt per meter square unit. Where K will be 6 into 10 to the power minus 3. I'm wrong bit, please. Sorry. Microwatt per centimeter square. Let's see the solution. NT is the number of microorganisms present is 100. Um, N naught initial number is 10 to the power 6. K value given. If you put in everything, your T will be in 51.16 seconds. Why I am showing you this particular problem? Because see, from 10 to the power 6 to 100, it is doing within a minute. Within a minute, 51.16 seconds. It's not a matter of joke. Within a minute, it is doing 51.16 seconds. Till 9 seconds left, almost. It is reducing the value to 1 million to 100, 10 to the 6 to 100. Now, chemical methods is applying, first of all, is by applying lime. Now, when you're applying lime means calcium is excess lime. When you're applying calcium oxide in excess, it will form calcium hydroxide. And this calcium hydroxide, obviously, it's hydroxyl ion. So we know from our alkalinity concept, that hydroxyl ion will take the pH of the water more than 10. Hydroxyl ion will take the pH of the water more than 10. And generally, microorganism cannot sustain very high pH value. It can sustain neutral pH value. If the pH value is higher, then the cell wall gets impermeable. It will not sustain high pH value as well as it will not sustain the low pH value. So generally, microorganism if it is high pH is higher, its cell wall gets impermeable. And as you are putting excess lime to water, obviously it will provide calcium hydroxide. And hydroxide ion means it is predominant in the pH more than 10. So eventually, when you are applying excess lime, it will find out calcium hydroxide, which will take the pH value more than 10. And in this high pH value, the microorganism cell wall will get impermeable. Will get impermeable. Effective and efficient killing is ensured. Effective, all destruction will be ensured. Fast rate of killing is also ensured. And future protection is also there. Matlab, whatever is the positive point, almost every positive point is there. Then why we are not that much fond of using calcium oxide for disinfection process? Because using this excess calcium oxide will give white color precipitate in water. You may have seen, if excess calcium oxide you are putting, it will give you a white color precipitate in water. To remove that white color precipitate, water has to be treated with carbon dioxide. To remove that white color precipitate, water has to be treated by carbon dioxide. And the treatment of water by excess carbon dioxide, is called as recarbonation process. Recarbonation process, and this recarbonation process is costly in nature. So usage of excess calcium oxide is almost having all the positive points. The only negative point is it is give a white color precipitate in the water, and to remove the precipitate from the water, we have to treat the water by carbon dioxide. And this treating of water with excess carbon dioxide is called as recarbonation process, which is very costly. The overall cost of the system gets increased. So the overall cost of the system gets increased. Now the second one is by applying metal ions. So we have done with the physical methods by applying heat and by applying light, and then we have entered to the chemical methods where we have done with the by applying lime. Now we are entering to by applying metal ions. Next will be by applying ozone, and finally there will be by applying halogen group of chemicals, which is the major point of concern of this chapter. Okay. Now this is given by applying metal ions. Now metal ions like copper, silver, gold is having high disinfection power. Metal ions of having like copper, silver, gold, you have seen that generally after the birth, the children are generally fed with the silver spoon. Why? Because this is nothing but a high disinfection power. There are scientific reasons are there. Some mythological aspects, some colloquial aspects are also there. They kill the microorganism by destroying their protoplasm. Quickly they kill the microorganism by destroying their protoplasm. Effective and efficient killing is ensured. Their effective and efficient killing, quick killing, all destruction is ensured. Fast rate of killing is also ensured. But if the concentration of chlorine is greater than 10 to 12 ppb, और ये जो मेटल आयन है इसका कंसंट्रेशन अगर 10 से 12 ppb के ऊपर चला जाता है, then it will be toxic to human health. तब ये टॉक्सिक हो जाते हैं. अगर कंसंट्रेशन ऑफ क्लोरीन 10 ppm से नीचे आते हैं, if the concentration of chlorine is actually less than 0.1 ppm, not 10, 0.1 ppm, then future protection will not be ensured. Future protection will not be ensured. So that is the reason 10 से 12 ppb. ppb is actually equivalent to what? Microgram per liter. Microgram per liter, and ppm, which is actually for milligram per liter. So if the concentration is more than 10 to 12 microgram per liter, it will be toxic to human being. But as per our think of residual concept, if the concentration is less than 0.1 ppm, future protection will not be ensured. Future protection will not be ensured. Future protection will not be ensured. Okay. Generally it will do how it will kill. It will kill the destroying the protoplasm. Generally they will kill, but if you are applying silver, it will make the cell wall impermeable. And treating of water with cell wall is called as electrocatalytic process. Treating of water with silver is called as electrocatadine process. Now, before going to the details of by applying halogen group of chemical, we need to go for another thing, that is by applying ozone. By applying ozone. Now, treatment of water by ozone is called as ozonolysis process. It is called as ozonolysis process, and the water is called as ozonized water. And the water is called as ozonized water. Ozonolysis process, and the water is called as ozonized water. नाउ दिस इज द मोस्ट साउट आफ्टर मेथड. इसके लिए सबसे ज्यादा चिल्लाया जाता है बाहर में, सबसे ज्यादा, क्योंकि ये सिर्फ इसको अगर आप अप्लाई कर रहे हो सिस्टम में, तो सिर्फ और सिर्फ ये डिसइंफेक्टेंट का काम नहीं करेगा. इसके सिवाय ये कलर ओडर को भी हटा देगा, टेस्ट भी इंप्रूव करेगा. तो नॉट ओनली इट विल एक्ट एज डिसइंफेक्टेंट, but also uh, but also it will remove color, odor, and certain taste from water. This is the most sought after method, and it is generally being used in the most of the cases, Western countries. It also removes the organic compounds like volatile organic compounds from water. Manganese and iron, that is a color causing two ions, will get also removed from water. Advantage is effective and efficient killing is ensured. Advantage is effective and efficient killing is ensured. Instant destruction by damaging the cell wall. Instant destruction by damaging the cell wall. It can easily detectable. So all the points, positive points: high residual power, effective and efficient killing, fast rate of killing, easily detectable, high residual power. All the advantages are there. But then also we are not able to use it in our Indian process because of its cost. Produce 1 kg of ozone, it requires 0.82 kilowatt hour of power. To produce 1 kg of ozone, it requires 0.82 kilowatt hour of power. And ozonator is the instrument which is which it is used to produce the ozone. Ozonator is an instrument which is used to produce ozone. And in ozonator, what will happen? There will be two electrodes, positive and negative, where high electric field will be applied. High electric field called as corona will be created, and air will be passed through that high electric field, which will give you ozone. So when oxygen, so what will happen? So this ozone react with hydrogen, it will give you hydroxium ion. This hydroxium ion will again react with ozone and give you hydroxyl radical. Hydroxyl radical. This hydroxyl radical will do the disinfection process. Have a look. Now we enter into the most important part of this disinfection process, which is by applying halogen group of chemicals. By applying halogen group of chemicals. Halogen group, according to the Mendeleev periodic table, it will be 7b, and it is fluorine, chlorine, bromine, iodine, and astatine. Fluorine, chlorine, bromine, iodine, and astatine. Now, we will use chlorine as the disinfectant, and applying the chlorine as disinfectant is called as chlorination process. Applying chlorine as disinfectant is called as chlorination process. We will use the chlorine as the disinfectant. Now, why not others? Is chlorine is only having disinfection power? The answer is no. All are having disinfection power, maybe better than chlorine, but they are having certain negativity in the process, so that they are not able to apply it. Wow. Fluorine, you know that fluorine, if it is more than 1.5 milligram per liter, it will be a problem. So constant concentration regulation will be there. It's a problem. Astatine, radioactive, not applicable. The chlorine, bromine, iodine, even bromine and iodine is better than chlorine, but in market they are only available in pellet form, tablet form, which is not useful for bulk process. Bromine and iodine, which will not be useful for bulk process. तो होता क्या है भैया, अगर they are not be useful for bulk process, and what will happen? As they are not useful for bulk process, that's why chlorine. So अगर आपकी जो टीम है 5 लोगों का, उनमें से 4 तो ऐसे निकल जा रहे हैं, अकेले एक क्लोरीन बचा रहता है, लेकिन क्लोरीन का disinfection power ब्रोमीन आयोडीन से कम है. Even ब्रोमीन आयोडीन is used sometimes in the domestic disinfection process, like बचपन में अगर आपका मतलब ऐसा होता था कि अगर कहीं पे कट गया कुछ हुआ, तो आप एक लाल कलर रेड कलर सॉल्यूशन लगाते थे. दैट इज नथिंग बट अ mercurochrome solution, which is the bromine solution. Iodine will be used in lot में disinfection process. If you are having throat problem, betadine solution जो होते हैं जिससे gargle करते हैं, या तो operation के बाद जो लगाते हैं betadine ointment, all are iodine. So it is nothing but the disinfection process. Can be used in medicines, can be used in domestic process, but for bulk process it will not be helpful. So chlorination process, directly we are entering to the chlorination process, the most important part of this process, of this disinfection thing. So when you're applying chlorine as disinfectant, it will be called as chlorination process. But when you are chlorine reacting with water, it will react with water if the pH is more than 5, it will form HOCl and HCl. It will form HOCl and HCl. This particular equation is called as hydrolyzation equation. This particular equation is called as hydrolyzation equation. This HOCl, hydroxychloride, will undergo, as it is not stable, as it is unstable, it will undergo uh, both way reaction, where the forward reaction will get enhanced if the pH is more than 7.5, and the backward reaction will be enhanced if the pH is less than 7.5. It will form H plus OCl minus, oxychloride ion H plus, and this particular equation is called as ionization reaction. So if you keep on increasing the pH, your OCl minus ion will be there more in the system, because forward reaction will get enhanced. And if we keep on decreasing the pH, HOCl will be there in the system, as backward reaction will get enhanced. Okay. Now HOCl and OCl minus, both are having same degree of disinfection. HOCl and OCl minus both are having same degree of disinfection. That means अगर किसी को मारने के लिए HOCl का जितना टाइम चाहिए, जितना कंसंट्रेशन को, OCl माइनस आयन का भी उतना ही टाइम चाहिए होगा, उतना ही कंसंट्रेशन के लिए. So I have already told you that OCl माइनस आयन का कंसंट्रेशन जो है, ये सारे कंसंट्रेशन आयनिक कंसंट्रेशन है, तो इट विल बी एक्सप्रेस्ड इन मोल पर लीटर यूनिट. इसका जो कंसंट्रेशन है, that will be directly proportional to pH value. Why? That will be directly proportional to pH value, because if you keep on increasing the pH value, OCl minus ion concentration will get increased, and HOCl is inversely proportional to pH value, because decrease in pH value will enhance the backward reaction, which will give you more HOCl in the system. A microorganism cell wall is negatively charged, तो HOCl और OCl माइनस दोनों ही सेम पावर ऑफ डिसइंफेक्शन है, लेकिन कौन ज्यादा इफेक्टिव है और क्यों, मैं बता रहा हूँ. जनरली माइक्रोऑर्गेनिज्म सेल वॉल इज नेगेटिवली चार्ज्ड. तो अगर आपके एक माइक्रोऑर्गेनिज्म की तरफ सोचिए, दो सेम माइक्रोऑर्गेनिज्म, सेम मास, सब कुछ सेम, एक की तरफ OCl माइनस आयन आगे बढ़ रहा है, एक HOCl आगे बढ़ रहा है. एक की तरफ OCl माइनस आयन जिसके तरफ आगे बढ़ रहा है, तो उसका सेल वॉल सेंस कर रहा है कि कुछ कुछ आ रहा है, क्योंकि microorganism cell wall is generally negatively charged. As another negatively charged ion is approaching towards the microorganism, it is sensing and it will get repelled, दूर भागने का कोशिश करेगा. Whereas when HOCl is approaching towards the microorganism, it will not sense anything and it will happily enter to the cell wall. It will destroy protoplasm. Surgical strike occurs. Who is more effective? HOCl. Why? Because HOCl is not getting any resistance from the microorganism. Ultimately OCl minus ion को ज्यादा टाइम लग जा रहा है, क्योंकि पावर सेम है, लेकिन microorganism is sensing that something is approaching towards it. So HOCl is more effective than OCl minus ion. So which is required in the system? HOCl is required, desired in the system, क्योंकि ये ज्यादा इफेक्टिव है. और HOCl आपको कब मिलेगा? जब pH कम होगा. pH ज्यादा होगा तो फॉरवर्ड रिएक्शन होगा, pH कम होगा तो बैकवर्ड रिएक्शन आ जाएगा. क्लियर? सो वी कैन से दैट effectivity of chlorination is inversely proportional to pH value, because if pH is higher, more OCl minus ion will be there, which is actually less effective than HOCl. And if to get more HOCl in the system, your pH value has to be less. Understood? That's why effectivity of chlorination is the inversely proportional to the pH value. Okay, have a look. Now, HOCl, that equation once again. So K, the ionization constant, will be equals to, ionization constant is the nothing but the multiplication of product, concentration of product by reactant. Multiplication of the concentration of product by reactant. So K is H plus into OCl minus by HOCl. And so K by H plus from this equation will be OCl minus by HOCl. Percentage HOCl. If there are two things in the system, so HOCl plus OCl, these two, both HOCl plus OCl minus is called as free chlorine. Combined, it is called as free chlorine. So a percentage HOCl is nothing but if two things in the system, percentage A will be A by A plus B into 100. So percentage HOCl is equals to HOCl by HOCl plus OCl minus into 100, where percentage HOCl can be defined as 1 by, if you divide by HOCl the whole system, this is the form, that's the first form. Second form will be if you replace OCl minus by HOCl, this segment, by K by H plus, it will be the second form. So there are two forms of percentage HOCl, and to have the same degree of disinfection, concentration of HOCl has to be constant. मतलब जनवरी महीने में अगर कुछ डिसइंफेक्शन प्रोसेस के लिए कुछ सर्टेन अमाउंट ऑफ डिसइंफेक्शन प्रोसेस माइक्रो ऑर्गेनिज्म को मारने के लिए जितना आपका HOCl का जरूरत था कंसंट्रेशन, दिसंबर में भी उतना ही चाहिए होगा. To have same degree of disinfection, concentration of HOCl has to be constant, and concentration of HOCl will be equals to chlorine dose और कितना percentage HOCl is available. Concentration of HOCl is equals to chlorine dose and the percentage HOCl available. Okay, that is second thing. So now we are going for the chlorine demand of water, that how much chlorine is demanded in water. क्या है? तो अभी तक हम लोग क्या पढ़ चुके हैं? हम लोग देखे हैं कि क्या क्या है प्रोसेस का, उसका हाइड्रोलिसिस रिएक्शन, आयोनाइजेशन रिएक्शन देखे हैं, उसका आयोनाइजेशन कांस्टेंट देखे हैं कि इफेक्टिविटी ऑफ क्लोरिनेशन हाउ डज इट वेरी विद द पीएच वैल्यू. उसके साथ साथ हम लोग देखे हैं कि व्हाट इज परसेंटेज HOCl, and also we have seen that what is concentration of HOCl, or all those things we have already covered. Now we are entering to chlorine demand of water. What is chlorine demand? Chlorine demand means the amount of chlorine required in a tank for disinfection process. जो चाहिए tank को, that will be called as chlorine demand, or we can say that the amount of chlorine consumed in the disinfection tank. मतलब अगर आप 10 दे रहे हो तो 5 आपको रेसिडुअल मिल रहा है, तो जितना है, कितना डिमांड है, 5. तो कहानी है कि आप क्या मेजर कर रहे हो, आप मेजर कर रहे हो कितना अप्लाई कर रहे हो, क्योंकि the applied amount will be in your hand itself. The applied amount will be in your hand, and then what you are measuring the residual amount, कितना बचा हुआ है. So chlorine applied, I have already told you that applied minus residual is equals to demand or consume. Okay. So chlorine demand means the amount of chlorine required in a tank for disinfection process. मतलब आप जो क्लोरीन डाल रहे हो डिसइंफेक्शन के लिए, वो जितना क्लोरीन वहां पे कंज्यूम हो रहा है उसको कहते हैं क्लोरीन डिमांड. ओके, नाउ बात यह है कि आप क्लोरीन क्यों डाल रहे हो. इधर थोड़ा सा कहानी में ट्विस्ट है. आप क्लोरीन क्यों डाल रहे हो? आप क्लोरीन डाल रहे हो पानी में क्योंकि आपको माइक्रो ऑर्गेनिज्म को मारना है. अब क्लोरीन उतना भी अच्छा बंदा नहीं है कि आपका बातें हमेशा सुन लेगा. If you are applying chlorine, there is certain consumption process. What will be the consumption process? When you are applying chlorine, आप डाल रहे हो, आपके मन में है कि माइक्रो ऑर्गेनिज्म को मारना है, लेकिन क्या करेगा टैंक में जाके, वो उसका खुद का प्रोसेस है, उसमें आप कुछ कंट्रोल कर ही नहीं पाओगे. When the chlorine is entering to the tank, when the chlorine is entering to the tank, first it will react with metal ion, कैल्शियम, आयरन, सोडियम, पोटासियम, जितना जितना मेटल आयंस है उसके साथ ये रिएक्ट करेगा और ये फॉर्म बनाएगा क्लोराइड. और जब तक इसका मेटल आयन, सारे मेटल आयन सिस्टम से खत्म ना हो जाए, ये मेटल आयन के साथ रिएक्ट करना छोड़ेगा नहीं. जब तक until and unless all the metal ions are getting finished from the system, it will not react with others. मतलब आप डालते जा रहे हो, आप सोच रहे हो कि माइक्रो ऑर्गेनिज्म को मारने के लिए क्लोरीन जा रहा है, लेकिन बी वेरी केयरफुल अबाउट दिस कॉन्सेप्ट. दिस कॉन्सेप्ट विल बी अगेन रिपीटेड लेटर ऑन. So what you are thinking that you are applying chlorine to kill the microorganism, but no, it is not killing the microorganism, because if the system contains a very small amount of metal ion also, then also chlorine will go to react with the metal ion and form chloride. क्लोरीन का सबसे ज्यादा एफिनिटी मेटल आयन के साथ ही है. Now then you will ask that what will happen if all the metal ions are getting finished. अगर सब कुछ खत्म हो जाने के बाद क्या होगा? आफ्टर फिनिशिंग ऑल द मेटल आयंस, उसके बाद भी क्लोरीन माइक्रो ऑर्गेनिज्म के साथ रिएक्ट नहीं करेगा. उसके बाद भी क्लोरीन रिएक्ट करेगा किसके साथ? एमोनिया के साथ, और बनाएगा कंबाइंड क्लोरीन और क्लोरामाइन. आफ्टर फिनिशिंग ऑल द मेटल आयंस, it will react with ammonia and form combined chlorine or chloramine. जब तक एमोनिया खत्म ना हो जाए तब तक ये क्लोरामाइन एमोनिया के साथ रिएक्ट करे कंबाइंड क्लोरीन बनाएगा. उसके बाद जब एमोनिया खत्म हो जाएगा, then it will start reacting with the microorganism. So first it will react with metal ion. Until and unless all the metal ions are getting finished, it will not react with others. Then it will react with ammonia and form combined chlorine or chloramine. Until and unless all the ammonia are not getting finished, it will not react with microorganism. After finishing of microorganism, whatever is left will be the residual. After finishing of microorganism, whatever will left will be the residual. So let me give you an example so that you can understand properly. So suppose this is chlorine applied. When chlorine is applied, first it is going to metal ion, then ammonia, then microorganism. Suppose first you are applying 5. All 5 are consumed by metal ion. You don't know anything. So keep on applying 5. Suppose 3 is consumed by metal ion finished from the system. How much is left? 2. That 2 is going to ammonia. Again you are applying 5. Suppose it is getting this 5. Again you are applying 5 and it is getting 1. Ammonia finished. Microorganism is getting 4. Again you are applied 5. Suppose microorganism is getting 2 and microorganism finished. So how much will be residual? So how much you are applying? 25 unit. Metal ion is consuming 8. Ammonia 8 is applying 6. Total is 22. Residual is 3. This is your chlorine demand or chlorine consumed. So why you are applying doesn't matter. Chlorine demand means, so you are actually applying 25 and getting residual 3. That means what you are thinking, that 22 is consumed by microorganism. Answer is no. The chlorine demand or chlorine consumed is actually the summation of all the chlorine consumed inside the tank for whatever may be the process, for reacting with metal ion forming chloride, reacting with ammonia forming chloramine or combined chlorine, and killing the microorganism. Is that clear? Maybe the killing microorganism is the least concentration taking process, but then also all the blame is going to that microorganism. Is that okay? Have a look. Now, now we are going for the different forms of chlorine. Now we are going for the different forms of chlorine. In 4 different forms, chlorine can be applied. So in 4 different forms, chlorine can be applied. One is hypochlorite, second one is chloramine, third one is chlorine gas and chlorine dioxide. What is hypochlorite? When hypochlorites is actually will be of 2 types. So when hypochlorites are used as source of chlorine, then the process is called as hypochlorination. When hypochlorite is used as a source of chlorine, then it is called as hypochlorination. And hypochlorite will be of 2 types: calcium hypochlorite and sodium hypochlorite. Calcium hypochlorite and sodium hypochlorite. Now, calcium hypochlorite is CaOClCl, where 30% chlorine is available. Calcium hypochlorite is bleaching powder actually, which is the CaOClCl, 30% chlorine is available. Sodium hypochlorite, where 10% chlorine is available, where that is bleaching where, and generally bleaching powder will be used as the source of chlorine, where chlorine dose is equals to bleaching powder dose and percentage chlorine available. Chlorine dose is actually equals to bleaching powder dose and percentage chlorine available, where bleaching powder dose is chlorine dose by percentage chlorine available. Okay, the basic thing. Advantage: it is the cheapest form of chlorine available. It is the cheapest form of chlorine available. It is easily available in the market and give good quantity of HOCl. It is the cheapest form of chlorine available. It is easily available in market and give good quantity of HOCl. Disadvantage is does not quickly dissolve in water, gives bad smell and taste, and it loses its power when exposed to sunlight. Actually, when it gives bad smell and taste, it is called as secondary problem, because to remove one particular problem you are applying this chemical, and when you are applying this chemical and it is creating certain extra problem, is called as secondary problem. So it is the cheapest form of chlorine available, easily available in market, give good quantity of HOCl. And disadvantage is does not quickly dissolve in water, give bad smell and taste. In secondary problem, loses its power when exposed to sunlight, excess quantity is carcinogenic. Loses its power when exposed to sunlight, and the excess quantity is carcinogenic sometimes. So when you are getting smell of bleaching powder from the water is not good for the health. So advantage is cheapest form of chlorine available. It is easily available in the market. Give good quantity of HOCl. But disadvantage is does not quickly dissolve in the water. Give bad smell and taste, which is called as a secondary problem. Loses its power when exposed to sunlight. And excess quantity is carcinogenic in nature. Then you are going for chloramine. Chloramine. Chloramine, we have already seen it that when chlorine reacts with ammonia, it will form chloramine or combined chlorine. When chlorine reacts with ammonia, it will form chloramine or combined chlorine. A chlorine plus water pH more than 5, it will form HOCl plus HCl. Ammonia plus HCl, if pH is 8 greater than 8, it will form NH2Cl, monochloroamine. That monochloroamine will further react with HOCl in the between pH 6 and 8, it will form dichloroamine. And this dichloroamine will further react with HOCl if pH less than 5, which will form nitrogen trichloride, which is carcinogenic. Among these three forms, in NH2Cl, in NHCl2 and NCl, so NCl3 is carcinogenic, leave that from our discussion. Monochloroamine and dichloroamine, monochloroamine is much better than dichloroamine. So pH should be higher of this case. But eventually, whatever it may be the process, monochloroamine or dichloroamine, all are much slower than the HOCl or OCl minus. It's a very slow process. In terms of power, monochloroamine is much greater than dichloroamine. But see in this sentence, HOCl is almost greater than equals to OCl minus, much greater than monochloroamine. It is much greater than dichloroamine. Disinfection power. No secondary problem is there. That's true. Does not lose its power when exposed to sunlight. That is also true. But disadvantage is much slower process. It's actually help the normal process. It helps the normal process. And pH induced process. You have seen all the equations are pH induced. It's a pH induced process. Now, I note that sometimes ammonia is added before chlorination so that when chlorine is busy with others, क्योंकि क्या है कि अमोनिया और क्लोरीन जब होगा तब क्लोरामाइन तैयार होगा. अगर क्लोरीन दूसरे कुछ काम में भी बिजी रह जाए तो वो क्लोरामाइन और कंबाइंड क्लोरीन जो बन गया सिस्टम में वो डिसइंफेक्शन प्रोसेस को धीरे धीरे चालू कर देगा. खत्म तो नहीं कर पाएगा, कर तो नहीं देगा पूरा पूरी, लेकिन चालू कर देगा, उसको सपोर्ट दे देगा, कांस्टेंट सपोर्ट देता रहेगा. क्लियर? नाउ chlorine gas. Chlorine gas, chlorine gas is another form of chlorine. Chlorine gas is pungent smell amber colored gas. Chlorine gas is pungent smell amber colored gas, 2.5 times heavier than air. It is pungent smell amber colored gas, 2.5 times heavier than air, and it is quickly dissolved in water and form free chlorine. Its pungent smell amber colored gas, 2.5 times heavier than air, quickly dissolve in water and form free chlorine. Quickly dissolve in water and form free chlorine. Everything is good. but the problem is storage and shipping problem is there. Chlorine gas, if it will be stored in the liquid form, if you release the pressure, it will be chlorine gas. But the basic problem is, if the concentration is more than 0.2 ppm, it will form trihalomethane, THM. So from methane, there are four hydrogen. Among those four hydrogens, 3 hydrogen will be released by chlorine. It will be CHCl3, chloroform. The concentration is more than 0.2 ppm, it will form trihalomethane or chloroform. And if the concentration is less than 0.1 ppm, no residual effect will be there, that we have already discussed. So we have to always maintain the concentration in between 0.1 to 0.2 ppm. You have to always maintain the concentration in between 0.1 to 0.2 ppm. Trihalomethane. Now, the fourth form of chlorine is chlorine dioxide. It is the best form of chlorine to be applied. No secondary problem, no THM risk, produce good quantity HOCl. The only problem जो चाहिए होता है वो मिलता नहीं, very expensive, cannot be stored, generation before application is required. It is very expensive, it cannot be stored, generation before application will be required. Now we are going for the kinetics of chlorination. So just have a look the different forms of chlorine. Now you're going for the different kinetics of chlorination, where percentage removal efficiency is defined by N naught minus NT by N naught into 100. N naught minus NT by N naught into 100, where N naught is the initial number of microorganism present and NT is the microorganism present at after time t. Log removal, another way to represent the R removal is log removal or log R, which is log 10 base N naught minus log 10 base NT. Log 10 base N naught minus log 10 base NT. That is truth. And third one, that actually it is the plot between number of microorganism present versus time. This is the N naught. which is the initial number of microorganisms, which is fixed. So when time increases, keep on increasing, the number of microorganisms will keep on decreasing, right? So at time t, this is actually nt. Nt is the number of microorganisms remaining at time t. This is nt, number of microorganisms remaining at time t. And this is your n naught minus nt, which is the number of microorganisms already killed at time t. Is it clear? Number of microorganisms already killed at time t. And this form is defined by nt is equals to n naught into e to the power minus kt, where t is the time of contact and k is disinfection rate constant. The minus sign is coming because as time increases, the number of microorganisms decreases. And from this, we know that efficiency is n naught minus nt by n naught into 100. If you remove this nt and replace it by this equation n naught e to the power minus kt, finally you are going to get eta equals to 1 minus e to the power minus kt into 100. So these are the two forms which is called as, on as per this graph, as per this plot, is called as Fick's law for disinfection process. It's called as Fick's law for disinfection process. Fick's law for disinfection process. Now, the fourth one is the relationship between the concentration of disinfectant and time of contact. The relationship between the concentration of disinfectant and the time of contact. For a particular process, C to the power n into T will be constant. For a particular process, C to the power n into T will be constant, where C is the concentration of disinfectant and T is the time of contact. C is the concentration of disinfectant and T is the time of contact, and n is called as dilution factor. N is called as dilution factor. That is the fourth equation. First equation is efficiency equation. Second equation another form, that is log R. Third equation is third and fourth means actually it is representing the Fick's law for disinfection on the basis of this particular plot. And fourth one is the relationship between the concentration of disinfectant and time of contact. C to the power n into t will be equals to constant. C to the power n into t will be equals to constant. Okay. Now we are entering to the process where we are going through the type of chlorination. We are going for the type of chlorination. There are 7 different types of chlorination exist. First one is plain chlorination, pre-chlorination, post-chlorination, double chlorination, super chlorination, dechlorination, and breakpoint chlorination. There are 7 different types of chlorination exist. Plain chlorination, pre-chlorination, post-chlorination, double chlorination, super chlorination, dechlorination, and breakpoint chlorination. Among these 7, the 7th one, breakpoint chlorination, is the most important one. Apart from that, we need to understand all in brief. Plain chlorination is nothing but, sometimes chlorination is the only mode of treating the water. Sometimes chlorination is the only mode of treating the water. Then it is called as plain chlorination. Generally, it is done when we are going for rainwater harvesting method. Generally, it is done when we are going for the rainwater harvesting method. What is rainwater harvesting? In rainwater harvesting, in the places where rainwater scarcity is there, in those places, sometimes rainwater is stored for future process. And in these cases, only chlorination is done because rainwater is assumed to be one of the most purest form of water available naturally. It is assumed that only microorganism is present in that water as the pollutant. So chlorination is only done to remove that pollutant from the water. Pre-chlorination, sometimes due to the heavy growth of microorganism, chlorination is done before filtration itself. Sometimes due to the heavy growth of microorganism, chlorination is done before filtration. It's called as pre-chlorination. Post-chlorination is the normal chlorination process. Post-chlorination is the normal chlorination process. Double chlorination is when in the system pre and post both the chlorination is done, is called as double chlorination process. When pre and post both the chlorination is done, is called as double chlorination process. Superchlorination is the chlorination concentration is more than 45 milligram per liter. If the chlorination concentration is more than 45 milligram per liter, then it will be called as superchlorination process. Dechlorination is the removal of chlorine from water, is called as dechlorination process. Removal of chlorine from water is called as dechlorination process. And this removal of chlorine from water is done by applying certain chemicals from outside. Those chemicals are called as dechlorinating agent. This removal of chlorine from the water is done by certain chemicals from outside. This is called as dechlorinating agent. As example, sodium thiosulfate, Na2H2O3. Na2H2O3 dechlorinating agent. And finally, we are entering to the most important type of chlorination, is called as break point chlorination. Called as break point chlorination. Before going to the details of breakpoint chlorination, have a look on the different types of chlorination thing. Now, breakpoint chlorination. What is breakpoint chlorination? Actually, breakpoint chlorination is nothing but a graphical representation. Don't read this second, third, fourth point. First, listen to me. It is a graphical representation of residual chlorine versus applied chlorine by performing DPD test. So you are going to put a plot. Don't go for the plot. Just x-axis and y-axis plot. Residual chlorine in the y-axis, applied chlorine in the x-axis. Residual chlorine and applied chlorine in the x-axis and y-axis. That will be the plot. But DPD is NN diethyl phenyl diamine sulfate. NN diethyl phenyl diamine sulfate is the DPD. Now what will happen? If your water contains certain residual chlorine and if you apply DPD to that, it will give you purple color and the concentration will be measured by colorimetry method. Clear? So what you are doing? Applied chlorine is in your hand. You are applying chlorine, you know the concentration. That's the x-axis value. Then you are taking water from the outlet, putting DPD there. If you are getting some color change, measuring the color of that water. Colorimetry method, standard chart will be given. Get the y-axis value. X-axis, y-axis plot. Clear? Now, don't go for the fourth point. Coming to this plot. Forget about the right side part. Forget about this segment right now. Forget about this segment right now. So there is y-axis and x-axis. Nothing else is there. So what is there? Now you are having only your y-axis and x-axis. Nothing else is there. Now, so this in the y-axis there is residual chlorine. In the x-axis there is applied chlorine. Suppose in your system there is no pollutant is there. मतलब कुछ भी नहीं है पानी में, एकदम साफ सुथरा डिस्टिल वाटर है, तब क्या होगा? इस मोमेंट में अगर आप अप्लाई करोगे क्लोरीन, जितना आप अप्लाई करोगे उतना ही बचा हुआ रहेगा क्योंकि उस क्लोरीन का कुछ काम नहीं है. Whatever will be the applied will be your residual. So if y and x axis value are same, we know y equals to mx plus c. If y and x axis value are same, c value is 0 because at time t equals to 0, nothing is there. The m value will be 1, tan theta will be 1, theta is 45 degree. So that line will be a straight line passing through origin, making an angle of 45 degree with the horizontal and vertical, whatever it may be. This line is called as ideal water line. क्योंकि पानी में कुछ है ही नहीं, तब अगर आप पानी में कुछ है नहीं मतलब ना तो है आपका मेटल आयंस, ना है आपका माइक्रो ऑर्गेनिज्म, ना है आपका एमोनिया, कुछ नहीं है पानी में. Then if you are applying chlorine, whatever you are applying will be your residual. It will be 45 degree angle with the horizontal. It is nothing but the residual chlorine versus applied chlorine. So the green line is the ideal water line, noted in the yellow water. 45 degree angle with the horizontal, ideal water line, the green line in the figure, main figure. Now coming to the real cases. Coming to the real cases. If you are applying certain chlorine, first chlorine will react with what? Metal ions. You keep on applying chlorine, no residual you will get. Why? Because chlorine is busy with metal ions and forming chloride. Until and unless all the chlorines are finished from the system, all the metal ions are finished from the system, it will not react with others. So this yellow line where you are not going to get any kind of y-axis value because no residual is there. So this yellow line will be your the metal ion formation line. where point B is denoting, all the metal ions are finished. So AB is actually depicting the formation of chloride and B is end of metal ion. B is end of metal ion. So if you start applying chlorine, so until unless all the metal ions are getting finished, you are not going to get any kind of y-axis value. Why? Because your residual value is not there. This blue line, suppose, starting from A to B. So at point B, who is there in the system? Metal ions are finished. Now ammonia is there in the system and microorganism is there in the system. When ammonia is there in the system, if you are applying chlorine, chlorine will react with ammonia and form chloramine or combined chlorine. कभी भी आपको कोई y एक्सिस वैल्यू मिलना नहीं चाहिए, क्योंकि कंबाइंड क्लोरीन बनने के टाइम पे भी आपको कोई रेसिडुअल क्लोरीन नहीं मिलेगा. But there is a problem that last point, apart from residual chlorine, chloramine will also give positive result to DPD test. जैसे रेसिडुअल क्लोरीन क्लोरामाइन टेस्ट के लिए पर्पल कलर का रिजल्ट देता है, वैसे ही रेसिडुअल क्लोरामाइन will also give the same result. Another test is there, orthotoluidine test, that is also there, but DPD test is the major to get the chloramine from water. तो भैया अभी क्या है, बन तो रहा है क्लोरामाइन, आप एक एग्जिट एक आउटलेट पानी को लेके डीपीडी टेस्ट कर रहे हो, मिल रहा है आपका पर्पल कलर, तो आप क्या सोच रहे हो, आप सोच रहे हो कि भैया रेसिडुअल क्लोरीन मिल रहा है, आपका कॉलोरीमेट्री टेस्ट में पॉजिटिव रिजल्ट है, इंटेंसिटी ऑफ कलर इज देयर, y axis value is there, so you are getting some y axis value, though you are getting for chloramine, but you need to plot because you don't know it is chloramine or residual chlorine, later on you will know. लेकिन इसमें भी एक हिंट है, आपको मैं पहले ही बताया था, दो इट्स स्लो प्रोसेस बट क्लोरामाइन विल is having certain disinfection power. Chloramine is having certain disinfection power. जैसे ही वो जेनरेट होगा, उसका डिसइंफेक्शन पावर के वजह से वो कुछ क्लोरामाइन कंज्यूम भी होता रहेगा, तो जितना आपको y एक्सिस वैल्यू मिलना चाहिए था उतना नहीं मिलेगा, उससे कुछ कम मिलेगा. And this difference between what you are getting and what you are about to get is certain chloramine is consumed to kill the microorganism. Certain chloramine is consumed to kill the microorganism. This pink color straight line B to C line you are getting now. That is a plot for chloramine. You are getting this B to C. Now, line point C is representing all the ammonia is finished. Point C is representing all the ammonia is finished, and line BC is representing chloramine or combined chlorine representation. अब point C के बाद कौन है, पॉइंट सी के बाद बचा कौन है सिस्टम में, मेटल आयन खत्म, एमोनिया खत्म, माइक्रो ऑर्गेनिज्म. तो पॉइंट सी के बाद जो आप क्लोरीन अप्लाई कर रहे हो वो माइक्रो ऑर्गेनिज्म को मारने के लिए जाएगा, तब भी आपको कोई रेसिडुअल नहीं मिलना चाहिए. लेकिन आपके सिस्टम में क्लोरामाइन है, जो क्लोरामाइन उस माइक्रो ऑर्गेनिज्म को खत्म करने में हेल्प करेगा. तो क्या होगा, जेनरेशन बंद हो चुका है लेकिन कंजम्पशन चालू है, आपका इनकम बंद हो चुका है लेकिन एक्सपेंडिचर चालू है, तो पैसा कहां से जाएगा, आपका सेविंग्स अकाउंट से. वैसे ही यहाँ पे जेनरेशन बंद है क्लोरामाइन का, लेकिन कंजम्पशन चालू है, क्योंकि ये बंदा माइक्रो ऑर्गेनिज्म को मारने पे पड़े हुए हैं. तो क्या होगा, जो ऑलरेडी जेनरेटेड अमाउंट है उसमें से उसका कंसंट्रेशन रेड्यूस होगा. The concentration will get reduced from the generated amount because generation is over, ammonia is finished, but certain chloramine is getting consumed to kill the or to assist in the killing process of microorganism. Clear? So C2D is actually representing the reduction in chloramine concentration to kill the microorganism, because after point C there is no generation in chloramine. तो डी पॉइंट क्या है, कब तक रिडक्शन होगा, जब तक ना सारे माइक्रो ऑर्गेनिज्म खत्म ना हो जाए. पॉइंट डी वो एक ऐसा पॉइंट है जहां पे सारे माइक्रो ऑर्गेनिज्म इज गेटिंग फिनिश्ड. So CD is decrease in concentration of chloramine due to microorganism killing process, and D microorganism is also finished. तो D को क्या कहेंगे, D को कहेंगे ब्रेक पॉइंट. और डी के बाद अगर आप फिर से क्लोरीन अप्लाई करते हो, उस क्लोरीन का कोई काम नहीं. दैट क्लोरीन इज कॉल्ड एज फ्री क्लोरीन रेसिडुअल, एंड द लाइन it will be, because after point D it will, the water is converted into what, water is converted into ideal water. So after point D, whatever chlorine is applied will be free chlorine residual that will show a straight line parallel to the ideal water line. Is that clear? Making 45-degree angle with the parallel line of the horizontal. So break chlorination beyond break point is called as break point chlorination. Chlorination beyond break point is called as break point chlorination. और ब्रेक पॉइंट पे जो रेसिडुअल वैल्यू है, मतलब जो वैल्यू है, ये वैल्यू किसके लिए है, ये सारे तो वैल्यू है क्लोरामाइन की कहानी. सो इट इज कंबाइंड क्लोरीन रेसिडुअल, और ये है आपका फ्री क्लोरीन रेसिडुअल जो ब्रेक पॉइंट के ऊपर वाला है. और पूरा जो वाई एक्सिस वैल्यू आपको मिल रहा है, दैट इज नथिंग बट टोटल क्लोरीन रेसिडुअल, nothing but the total chlorine residual. So see, start 2, start 3, star 1. Start 2 is combined chlorine residual. Star 1 is total chlorine residual, and star 3 is free chlorine residual. So your total chlorine residual is a summation of combined chlorine residual and free chlorine residual. Is that okay? For further details, you can go to an app class of breakpoint chlorination. Have a look. Just a minute, guys. So that is the end of the surface water treatment process, where we have gone through the plain sedimentation, then coagulation flocculation, then disinfection, then filtration, then disinfection. Now we'll briefly go to the groundwater treatment process. We will briefly go to the groundwater treatment process. If you remember, while discussing with you the prelude of the treatment process, I have shown you one groundwater treatment scheme there. I've told you already that as groundwater is devoid of suspended and colloidal particles, so there is no use of plain sedimentation as well as coagulation flocculation. But the main problem with groundwater is it is devoid of oxygen. So first there will be aeration technique, then there will be water softening process because hardness will be higher of the groundwater. Then there will be filtration because dissolved solids are present. Then there will be disinfection. And finally it will get supplied. So aeration technique, filtration and disinfection we have already discussed. Aeration and water softening process we will discuss here briefly. And apart from aeration and water softening, we will discuss for certain other process also. Aeration is two things will occur during aeration process. Putting of extra oxygen to water is called as gasification process. Also, it is also absorption process. And removal of excess carbon dioxide and H2S from water. Removal of excess carbon dioxide and H2S from water, which is desorption process or degasification. Removal of gas, that's why degasification process. Okay. The working principle of this process is nothing but concentration gradient. dC/dt. Concentration gradient means dC/dt. Rate of change of concentration with time. If the actual concentration is less than the saturation concentration, then absorption will occur. If the actual concentration is less than the saturation concentration, then absorption will occur. And if the actual concentration is more than saturation concentration, then desorption will occur. So absorption will occur when we are going for proper process of gasification and desorption will occur when we are going for the proper process of degasification. The rate of change of concentration of any gas depends on dCdt. What I've written is the concentration gradient. This is your concentration gradient. So dCdt is positive for absorption and negative for desorption process. Importance of addition technique: by the removal of H2S and carbon dioxide gases, water becomes odor free. We are going to brief discussion. For the details mathematical discussion, you need to go for a course in the app, my course. There we will discuss the groundwater treatment in details. We will. By increasing the oxygen content, the taste and quality gets increased. Aeration can also remove iron and manganese present in water. These are color causing ions. Three things is happening simultaneously. Aeration is carried out by two ways. One is the dispersion of water into air, and another is dispersion of air into water. It is carried out by two ways: dispersion of water into air. Dispersion of water into air means water is under your control. The flow rate, how much water is going to get discharged, everything under your control. Air is not under your control, where the dispersion of air into water means the air is under your control, not the water. And the dispersion of water into air will be carried out by three ways. Three methods. One is foundation aerator. What will happen in foundation aerator? Suppose this is the system where a foundation will be installed. Water is there. We will take the water, sprinkle down from here. Take the water and sprinkle down. And during sprinkle down, jet will be created. So during sprinkle down, it is exposed to the air, called as foundation aerator. Basic thing. Second one will be cascade aerator. In cascade aerator, there will be an arrangement like this, and water will be discharged from here. And water slowly discharged from here, slowly moving down according to their height difference. You will get exposure to the air. Another one is tree aerator. Foundation aerator, cascade aerator. Another one is tree aerator. In tree aerator, two types of tray will be there. There will be a tray perforated at the top, and there will be another tray in the bottom, which is collection tray. Perforated tray. To that perforation, water will slowly come down to the collection tray, and it will get exposed to air. That is tray aerator. Now there is mistake in there. Water softening process. Water softening process. The water softening process will be carried out by, first of all, boiling process. In boiling process, only impurity hardness will get removed. Only impurity hardness will get removed in the boiling process. And second will be by applying lime. By applying lime, remove all carbonate hardness, remove non-carbonate hardness of magnesium, but add non-carbonate hardness of calcium. Like lime is what? Calcium oxide. If you react with magnesium sulfate, non-carbonate hardness of magnesium, it will form calcium sulfate plus magnesium, calcium oxide, magnesium oxide. So this is nothing but non-carbonate hardness of calcium. So eventually, this is cannot be removed, non-carbonate of hardness of calcium. That's why we are going for lime soda process. Lime and NO2, that is soda ash. So lime will remove the carbonate hardness and non-carbonate hardness of magnesium, what we have already seen, and soda ash will remove the non-carbonate hardness of calcium, what is actually remaining in the system. Fourth one is ion exchange method. I have told you previously also, it's zero hardness is achieved, efficiency is 100%. Now, what is ion exchange method or zeolite process? In ion exchange method, a cylindrical type, there will be zeolite adsorber. See the term adsorber. It's not absorber. It's not a chemical process. Adsorber. Its sodium aluminosilicate will be there. The adsorbing capacity will be in between 15 to 100 kg per meter cube. So obviously the volume will be kg per day in conversion concept. The volume will be Q in mld into concentration milligram per liter by adsorbing capacity. This one will be kg per day, so it's kg per day meter cube, so eventually it will be meter cube only. Okay, it will adsorb. It will do this in the outer part, the outer level of the molecules. Rate of flow will vary in between 0.2 to 0.6 meter cube per minute per meter square, but surface area will be Q by RF, where this one is 0.4 meter cube per minute per meter square. Height will be volume by surface area, and zero hardness can be achieved by ion exchanger method. Okay, we're just going for a problem. Find the diameter and height of the ion exchanger required to handle 2 mld of water with hardness 150 milligram per liter as calcium carbonate. The capacity is 90 kg per day meter cube. Water is passed at a rate of 0.4 meter cube per minute meter square. The surface area will be Q by ROF, that is Q is given. Q is 2 mld, so it's 2 into 10 to the power 3 meter cube. By ROF is this. It's 3.4 centimeter square. So pi by 4 d square will be this. D will be 2.10 meter. And volume is Q into Yi. It's nothing but Q in mld into Yi into milligram per liter. Y means it's C only. Concentration of hardness. By this is adsorbing capacity, which is in kg per day meter cube. That is coming as 3.3 cube meter cube. Height will be volume by surface area will be 0.96 meter. Very basic problem. It is just showing you the thing. Yeah. Like going for such different process like desalination process. Desalination process means it's the removal of salt. D means removal. So desalination process means removal of excess salt. It is done by three things: reverse osmosis, electrolysis, and distillation. Reverse osmosis and electrolysis is also called as membrane filtration process, and distillation is there. One thing I should tell you that there's while you're going for this process of lime soda process, the chemical requirement in lime soda process, there is certain things. If you are going for that further discussion, you need to go for this. This is not there in the crash course, or I should not tell to go through that. But for better understanding, we'll go to the courses in the app. So lime soda process will provide that chemical requirement. Just I'm putting requirement is estimated by two methods. One is approximate method. Another one is exact method, done by two-way approximate method and exact method. So when we are talking about, just keep this in mind. So when we are talking about approximate method, then in approximate method is used. Approximate method is used when hardness data are given. An exact method is used when ionic data is given. Exact method is used when ionic data is given. Now again going to the desalination process. But reverse osmosis and electrolysis, both the process requires the use of membrane. That's why it's called as membrane filtration. In reverse osmosis, two chamber will be there. In one chamber salt water, another chamber fresh water, separated by a membrane. In the salt water segment, extra pressure will be provided. So salt water will try to move towards fresh water, and the membrane will restrict the flow of salt particles. Electrolysis, two membranes will be used as cathodes and anodes. Water high electric field will be required. It is moreover used in medical sciences. The salts ion will be dissociated into ions. Cations will be go to cathodes and anions will go to anode, and they will restrict the flow of ions, and they will discharge the particle free water, discharge salt or ions free or particle free water itself. There is one is uh, thermal distillation. In thermal distillation, that is the third one, is two chamber. Vaporization of water will be done in one chamber, and the vapor contains pure water because salts will not get vaporized in that particular temperature, and this vapor will be collected and it will get condensed in another chamber, which will be the, so condensed water will be salt free water. Condensed water is salt free water. That is thermal distillation. Another one is fluoridation and defluoridation. If fluorine is less than 1 milligram per liter, it's a problem. Then fluoridation is required. Add NaF water. If it is more than 1.5 milligram per liter, defluoridation is required. It is done by two-way treating with activated alumina, which is called act as adsorber, and Nalgonda technique. Nalgonda is a city in Tamil Nadu. Nalgonda technique, where in the Nalgonda technique, alum, lime, and bleaching powder will be used as the three chemicals. Okay, so that's the basics of the groundwater treatment part. So once again, I am going to this thing that just recalling the thing. Before that, what we have discussed today, first of all, we have discussed the disinfection process in details, and then we have entered to the groundwater treatment, where aeration, then water softening, type of aerators, water softening process, and ion exchange method, its problem, then desalination process, then fluoridation, defluoridation. Okay, so we have completed the process of water treatment. So all the process of domestic water supply is done. Now distribution system is left, that we will discuss later. In the next class, we will enter to wastewater treatment. I am just completing the theoretical aspects of these chapters. Then finally, we will go for problems and continuously for 2 to 3 classes. So next chapter, we will enter to the wastewater engineering directly. So once again, if you don't have the Unacademy learning app in your mobile, please go to your Play Store and type Unacademy learning app. Install Unacademy learning app in your mobile as soon as possible, because there we will get the subscription option for the Git and EAC plus courses, where you will get the personal monitorship, set of questions, notes, and you will get the lectures of the top educators of Unacademy. And while taking the subscription, don't forget to apply my code SEN10 ACN10. Don't forget to apply my code SEN10. Don't forget to apply my code SEN10. My code. If you apply it today, you are going to get 10% direct discount from the above mentioned value. And New Year gift to the civil engineering students who are evolving for GATE 2022. English and Hindi, both the languages batch is going to start launch on 28th December 11:15 a.m. 28th December 11:15 a.m. 28th of December 11:15 a.m. the batch is going to get start. And when you're going to get this batch, don't forget to apply my code SEN10. And Unacademy is launching another combat, that's on 29th of December 6 p.m. Another combat for Unacademy, 29th of December 6 p.m. Enroll now for free. Register now. You this combat, you will understand where is your position, and also if you crack it, then you will get for first 3 positions, you will get 3 months get an EAC subscription or equivalent Amazon voucher, or 4 to 50 for the rank 4 to 50, everybody will get rupees 500 Amazon voucher each. To crack the course, unlock code crack get. Unacademy combat is going to launch on December 29, 6 p.m. The web paper will be set by the topmost educators, and you will be provided with the live video solutions. Thank you for this session. We'll see you tomorrow. We'll start wastewater engineering. Thanks a lot.